In our lesson today, we are going to be working with exponential equations and learn how to solve them.
One of the most popular choices by parents in the Bay Area is Tutoringisus. We offer college advising, tutoring services, SAT and ACT test prep all under one roof. Where hard work achieves dreams, Tutoringisus is here to help.
The first thing we need to learn is the property of equality for exponential equations. And what it says is that if we have an equation in this form, then if b is a positive real number other than 1, then b to the x will equal to b to the y if and only if x is equal to y. Let's look at an example. If we have 3 to the x is equal to 3 to the 5, if the bases are the same, then the top will equal each other. We can say that x is equal to 5. Another example, if we have 2 to the x minus 1 equals to the 2 to the 5, since the bases are the same, we can conclude that x minus 1 will equal to 5, and then we just simply solve for x, and x will be 6. And you can always go back and check. You put 2, 6 minus 1, would that equal to 2 to the 5? Yes, it does. 2, 6 minus 1, that's 2 to the 5, will equal to 2 to the 5. We're going to go ahead and solve some of these equations, and we'll only be doing odd numbers. So we'll be working on number 5, 7, 9, 11, 13, and 15. Let's get started. Number 5, it says that 7, 3 to the x plus 5 equals to 7, 1 minus x. The bases are the same, so the top will be equal. 3x plus 5 equals to 1 minus x, and now I solve this equation. I bring in the x this side. That gives me 4x plus 5 equals to 1, and I move my 5 to the other side, and I have 4x equals to negative 4 divided by 4 divided by 4, and x is equal to negative 1. And I'll go back and check, make sure that makes sense. We'll have 3 times negative 1 plus 5 should equal to 1 minus 1. 3 times negative 1 is negative 3 plus 5, and 1 minus minus, that's a positive, so the 1 plus 1, 5 minus 3 is 2, and 1 plus 1 is 2, and check. So my answer is x equal to negative 1. Next is problem number 7. 5x to the negative 3 equals to 25x to the negative 5. Now, the bases are not the same. This is a 5 and this is a 25. So I need to convert one of these so the bases are the same. Well, obviously, I can convert the 25, but not the 5. So now I can do 5x to the negative 3. A 25 is a 5 squared. So this is going to be 5x minus 5. And by the exponent rule, this is going to be multiplied. So now I have 5x minus 3 equals to 2x minus 6, as this will be multiplied in here. As the 2 will be multiplied, will be distributed inside. Now the bases are the same, so x minus 3 should equal to 2x minus 6. And solving this, so I'll move this to the other side, this negative x, and I'll move this to the other side, plus 6. Doing this, plus 6 here, and minus x here. This cancels, and 6 minus 3 is 3, and then 2x minus x is x. So that's my solution. And I'll go back and check. I'll have x, which is 3, minus 3. Since I'm doing it against the 5 base, so it has to be substituted into 2x minus 6. and that would be 2 times 3 minus 6. 3 minus 3 is 0. 2 times 3 is 6. 6 minus 6 is 0. So my answer is correct. Problem 9. 3 to the x equals to 7. Now, these are not the same basis, and they would never be. 7 is a prime number, and so is a 3. They are not related. So now I need to use the inverse property. The inverse property, inverse of an exponent, is the log to the same base. Just remember that. And if you don't know that, I already have a lesson that talks about inverses of log and exponents. Bring my x down. I would need to take the log to the same base of this side. So this would be log base 3. And I'll have to do the same thing for this. Log cancels with log, and x comes down. I'll have x equal to log base 3, 7. And that's it. Problem number 11. 49 5x plus 2 equals to 1 over 7, 11 minus x. I see a 7 that is a common between the two bases. So if I change this base to a 7, I end up with 7 squared. And then I'll have the 5x plus 2 still there. Well, 1 over 7 is nothing but a 7 to the negative 1, right? 11 minus x. So now I have a 7 that is common base between both. So I'm just going to distribute this there and distribute this there, and I'll have the two sides equal and solve for my x. So now all what I have to do is just distribute the 2 inside and the negative 1 side. 2 times 5x is 10x, and 2 times 2 is 4, and I have minus 11 plus x. I'm going to go ahead and move my x to the other side. Negative x, negative x. I'm going to end up with 9x plus 4 equals to negative 11. And I do minus 4 here. So I have 9x equals to negative 15. Then I got to divide both sides by 9. And I end up with x equals to negative 15 over 9. And I can reduce that, would be negative 5 over 3. That's your answer, and you could go back and check and make sure that the left side would equal to the right side. Problem number 13. 7, 5x equals to 12. Now, looking at and I see that the 7 and the 12 has no relationship between each other, and I cannot convert either one of them. So I will have to use the inverse property of log. To bring the 5x down, I'll have to take the inverse of the base, which will be the log to the same base. And I'll do the same thing here. So that cancels out, and I bring my 5x here, and that will be log base 7 of 12. Divide by 5, and x equals to log base 7, 12 over 5. Problem number 15. I have 3 times e to the 4x plus 9 equals to 15. When I have an equation like that and I have some numbers in both sides, I can reduce that. I just subtract 9 to make it easy, and that would be 3e to the 4x equals to 6. And I can also reduce this 3 with this 3, and I'm going to have e to the 4x equals to 2. Now, there's no same basis here. So since I have an e, I'll take the natural log of this side and also the natural log of this side. This will cancel out, and I'll have 4x equals to the natural log of 2, and I divide this side by 4, this side by 4, and my solution will be x equal to the natural log of 2 over 4.
One of the most popular choices by parents in the Bay Area is Tutoringisus. We offer college advising, tutoring services, SAT and ACT test prep all under one roof. Where hard work achieves dreams, Tutoringisus is here to help.